You're incredibly prolific. You have been an academic. You continue to be an academic. You founded Databricks. Those of you who don't know, Jon's the founder of Databricks. And you continue to build really impactful projects. You're creating startups. How do you do it all?
Have great students. What can I say? I think that it's like everything I'm trying to do is starting with a problem. What problem try to solve? And you try to figure out the kind of problems which are going to have to be, to be longer term, right? It's like your solution, whatever you are doing, it's only as important as the problem you are going to solve. Because if you don't solve a particular problem, why would people use what you have done? And this is true both for systems, but theory, everything. So I think that trying to figure out, to understand what problems you are trying to solve, I think it's the first very important step. And then when you try to do that, you try to think about how do you pick the problems. It's like a lot of them are, trying to figure out, looking at the trends out there and see where, because the trends is something which is hard to change. And you want to, in some general, to bet to be on the right side of the trends, right? That's kind of the high level.
Okay.
And of course, the other one, you have to have, great students and, let them, solve the problems and get out of the way.
So, a lot of the advancements are being pushed right now by academia. Like, I see so much innovation coming up there. And many universities seem to be challenged by just the lack of compute in academia. Your students seem to have figured out a path forward and seem to be successful in just creating projects that the whole community now can leverage. vLLM, Chatbot Arena, LLM Arena, all of this is coming from your lab. How are you able to do that? And how are graduate programs moving into these incubator programs?
Yeah, so again, you start with a problem and then you try to make sure that people, the students, they don't learn too early what they cannot do, right? So I think this is one of the keys. I am old enough, so I remember during my PhD I was attending these conferences at SOSP, the premier conference in operating system, and there were then panels about the operating system research is dead, because at that time this was I don't know, what is 96 or something, 95 I think. It was my first SOSP conference I attended. And operating system is dead because Microsoft is 90% of the operating system market, and it's like a few percent Apple and a few percent of this kind of Unix vendors at that time. And of course, after that, it came Linux, which it was very disruptive. Later on, actually, when I come to Berkeley, we have this kind of labs, and it was this kind of things about, the industry, in that case was Google, are doing all this kind of great distributed system and so forth. So we are going to, have ideas, build prototypes, and at the end of these labs, we are going to put together a demo. Everything put together, we were putting together. And we were lucky then, because of this kind of rise of the big data. So everything was new, Cloudera, Hortonworks, Hadoop, right? Yeah. And we have collaborated with all these people, who from industry. And we saw this kind of openings for doing something which mattered then, which was Spark and before Mesos. And I think that was one thing which is started to, give confidence that you can actually have an impact, despite the fact that you are in academia. And since then, we are trying to, to maintain that confidence and tell people, you can do actually more than you you believe you can do. And then, yeah, it's true. I mean, it's like, it's, the lack of resources is kind of massive. But, for inference, you don't need as many resources like for pre-training.
Yeah.
So it's hard, but in general, you can do more than you think you can.
Yeah. I'd love to get a sense of like, what are you most excited about? You've got so many projects that you're working on. Where's the most excitement for you?
Yeah. So I think a few things. So one of the excitements, it's about, obviously, I'm coming from the system side, and I think that the AI stack, and I think I'm still very excited about that, and it's obviously like we see everything. It seems more and more vertically integrated, right? Because you want to use all these resources more efficiently. Everyone is doing that. So I think that direction is going to continue, and it's going to be interesting how this is going to play out. The other trend, obviously, is about this using the code assistance for optimizations and so forth, system optimizations, kernel optimization, and so forth. Right. So I think ideally you want to see how that also will play out and will fit in. Like we have so many accelerators. So, like in particular, one problem I think there is that because you can think about it, you have so many accelerators, right? Today, it's of NVIDIA, it's AMD, it's Trainium. You have your own chips here, yeah. And TPUs and so forth. And you want to use them. On the paper, they are very high performant and so forth. But it's still everyone what telling you is like the software stack is not there, right? Right. It's very hard to write a high performance kernel. I mean, it's hard to write high performance kernel even for NVIDIA. Yeah. So I think that's kind of a problem that, and I think that is going to be solved because it's pretty contained, right? It's like you can, once I have a kernel which is kind of run correctly, I should be able to have all the tests and so forth, so to run on a different and optimize on a different hardware. But I realized more recently that actually the problem is not that one. The problem is that these stacks are not, they have a lot of bugs. And there are bugs at all levels. Hardware level, firmware level, software level, right? Yeah. The documentation is out of date. Yeah. So it's not that you are going to try to optimize something for a clean, environment. Yeah. Like, talking about RL. Yeah. It's not. It's a very, very messy environment. So actually that's a kind of the problem because you need to generate code which kind of avoid and goes, the bugs and so forth, avoid triggering them and things like that. Yeah. So I think that's one aspect, I think, which is exciting. The other one is like, at a higher level, it's how do you build reliable AI application? By reliability means predictable and so forth. I do think that one of the biggest problems that confronts today's AI because despite all the promise, it's really going to be very successful only if it's reliable, right? And especially for the high value use cases. Yeah.
So speaking of RL, since we talked about it, do you think it's actually scalable to the point that it becomes absolutely useful? Do you think it's here to stay? We've looked at RL over the years.
I'm biased, right? We work on RL for, early on for almost 15 years, 14 years. So we built Ray, actually, the main library in Ray. It was RLib, it was reinforcement learning. And that was the main library for a while. I think that RL will have more and more impact. And there are several reasons for that. If you look in the past, one of the challenges of RL, now reflecting back, was that it was very hard to integrate in the existing workflows. Processes. Like you want to do it in an enterprise and so forth. It wasn't easily being integrated. Yeah. And I think that one of the main challenge. I'll comment more on that. But today, it's like if you think about what an agent is, like in the simplest definition, it's an agent, it's a large language models, which uses some tools, in particular, browsing the web, whatever, or calling a database. But, if you think that, you already have the setting for RL, right? Because that's kind of agent also in almost in the RL sense. So you already have that, right? So you let it, this agent, collect traces and so forth. So there is no longer a problem about fitting in that workflow. It's already there. And I think that's a big deal. The other thing, obviously, why do people use RL? Is because with RL, you can learn new things, new solutions, right? That's how you have exploration and so forth. So now these large language models, and this is very relevant, are trained on all the data you can find.
Yeah.
If you don't have enough data, you buy other companies to get more data. But that's kind of clear, right? But then it's like, so how you add more data, and this RL, it's a source of providing you more data.
Yeah.
And you have to think about, like analogy, or not analogy, but you have to think like AlphaGo, right? The AlphaGo, right, is like, it has different stages. In the first stage, because people say, now what is RL different is that you have this kind of large language models which are already very powerful, and you don't need to do it from scratch. But it's again, if you think about the AlphaGo, there are a few things to keep in mind, because there are many papers now about which are published, basically say, RL is not very useful, it's only elicit information from, like knowledge from the base model, all of these things. But if you have to think at AlphaGo, actually there are a few stages. And the first stage, it's actually building a supervised model based and we train it for all the games in the history. Yeah. Right? They are played in the history. Yeah. So that's the first one, right? And this is equivalent with the LLM being trained on all the kind of human knowledge. But then you have the next stage, which is kind of the RL stage, is a self-play. So you are going to start playing these kind of models. And then when you are going to play against each other, you are going to learn new kind of moves in that particular case, right? Reinforced moves which are not in the previous games. So that's kind of new knowledge. And that's what makes actually AlphaGo performing better than humans. And then it's a last stage MTCS, which is basically doing a little RL, but more efficiently. You basically learn a reward model. But that's kind of, you have to think about that. That's a parallel. Now, the problem is that RL is notoriously sample inefficient, right? You need to spend a lot of compute in order to get great results. And that was true back then. It was much more, you needed more compute than you have than supervised learning. Right. So, and for obvious reasons. So if you think about RL, it's going to be pretty computer intensive to get great results, right? Yeah. Yes, if you do it a little bit, you are not going to get great results, but your conclusion will also be wrong. So I think that's kind of, and because of that, because you can accumulate new knowledge, because you can come up with eventually new solutions, and which are not in the base model. But the base model, you can, for every next token, you have some probably non-zero probability, in theoretical sense, to pick any other next token, right? It's about the probability distribution. So the base model, in theory, is like, it can also derive any solutions. The question is, of course, the probability distribution, how likely it is. What RL is doing, it's modifying the distribution. So to learn, to make some moves which are not before, or some generating next tokens, we generate new solutions more likely than the base model. So yes, I think that, but there will be more techniques like this kind of evolutionary algorithms, like in AlphaGo and so forth. Yeah. But in all cases, for RL also to be successful, which was also true many years ago, it's about this kind of verification, right? It's a reward function, right? You generate a solution. How do you know it's good? Right. With the games, which was very successful early on, that's a question. It's addressed pretty clearly, right? You play a game of Go or you play a game of chess. You know when you win and when you lose, right? It's unambiguous. It's very clear, right? But when you try to apply RL to more kind of domains, that can become much more ambiguous, and ambiguity is going to hurt you, right? It's like the more precise you have kind of this verification generating this kind of reward, the faster and progress you're going to make.
So let's switch a little bit direction, but with the results we're seeing with RL, assuming we have all of the compute, assuming we solve some of these problems, do you anticipate using these kinds of solutions for systems problems, systems efficiency,
Absolutely.
kernel building, these kinds of things? Where do you see the applicability?
There is no reason not to have more, to use RL and so forth for system problems. People use it also before. It's again, the key, it's about, there are many things you have to do, but the key is about, so first of all, what makes RL inefficient? There are a few things. It's like one, it's about if you need long trajectories, and then if you have a lot of choices at each step, right? A lot of moves, right? The games is also nice, and that was an early success because you are limited in the number of moves you can make in a game of chess or Go, right? You are limited, right? But in other domains can be it's also continuous moves, not discrete, right? These actions, right? You can take. So the more you have to explore, and the longer the trajectory, even more, because it's exponential growth. So that kind of makes challenging. So I am saying that because in order probably to make the most effective, you need to isolate from your system what is kind of important to limit the kind of choices you have. You can have an algorithms of scheduling and so forth. There are a few knobs you want, or a few actions, or what you want you want to limit the space, the environment, and the action space in order to be much more effective. And that will take some kind of domain knowledge to know what is important or not.
A question for people who are in the enterprise right now. What should enterprises be doing to prepare for this world? What kind of infrastructure changes should they be making? What are some transformations that are happening in the enterprise to prepare for AI doing more?
Look, I mean, the enterprises obviously right now it's still, you try very hard to balance between, not missing out and investing in things which will not pan out, right? So I think as an enterprise, and everything is not only an enterprise. First one, you want to prove the value of what you are doing, right? So I would so that's one thing. And there you try to do that as quickly as possible, whether you are going to use homegrown systems or maybe you can leverage other systems out there, but that's kind of the first thing. This is what startups are doing, right? You have all these startups, they are starting with, I'm going to use OpenAI, I'm going to use Gemini or so forth, and then, try when they are successful, then they try to reduce the cost and so forth, maybe bring more in-house, use Llama and other open source models, and in addition to that, to reduce, again, the cost and vLLM or whatever. So I think that's what you are going to see in the enterprises. Of course, they have a little bit more, there are more constraints because of the data and so forth. But that's what they try to do. It's like, and then some of these will be successful, some of them will not be as successful. And then you are going to, to double down on things which have been successful, right? Like customer support or whatever. Everyone is trying to do something like that, or some for their tools.
What is the role of evals in all of this? What is the role of evals in all of this? Like, how do you see evals sort of like permeating the enterprise?
Evaluation. Evals. Look, I think it's very important. Like I mentioned about one thing of what I think is the most important is how do you know the answers are reliable, right? And of course, we can go to LM Arena right now, and this is one of our projects. And it's difficult. So what makes things difficult here, to transition, is that the most successful AI application today, they have humans in the loop, right? There are code assistants and, like we discussed, customer support and so forth. So you have humans interacting with these systems. Now, humans, they have preferences, right? And, this is this kind of the debate, like, should we trust humans in evaluating? Yeah, you should trust the humans to evaluate it, because the humans are the ones to interact ultimately with these large language models, right? And the humans, they do have preferences besides the factuality of the context or content, right? It's not only that, right? We always like something, you have the same content, don't you like to write that content from a well-written blog or articles, right? It's the same thing. You want to hear, like the same content being delivered with, nice, beautiful slides and so forth, and by someone who maybe could be funny or whatever. Absolutely, right? So fundamentally, it's about human to AI application interaction. So you need to understand that what are the preferences? You need to quantify them. You want to factor them out. And I think a preference is like many things, like longer answers, right? Some people prefer longer answers. Some people prefer concise answers. Emojis, some of them prefer emojis, some of them, So, but the point here is that you need to understand these preferences and you need to quantify them, how much is going to improve, like for instance, Arena score. And you can then factor out what happens when you factor out. And we've done all of these things. But this is the main point. It's fundamental. And it's fundamental, I don't understand why people really ask that, because even with applications, right, with the software application, we have, UI, UX, right, the designers, right? You guys, have a lot of designers about what is the most effective way for people to understand how people interact with Facebook and so forth, and your applications, right? It's true also for anything people build that other people interact with. It's like microwave ovens and cars and so forth. So that's kind of, I think that it's very important, right, to understand. And for any kind of applications, which people interact with AI, because, there are different AIs, different kind of artifacts.
Yeah. I know we're almost out of time, but I do want to ask one question for the data people in this audience, and which is, how do you see the world of traditional analytics and generative AI workloads and data for AI converging? Do you see an interplay there? Do you see a world where analytics disappears and it's all AI?
They are coming together.
They are coming together.
I mean, like, look, I heard that 2 weeks ago at Databricks, our Data Plus AI it's called Data Plus AI Summit, right? And we called that for a few years. Fundamentally, like everyone is going to tell you, the data is very important again, going back to, you believe that, obviously. So that's kind of the things, right? It's like the data, it's extremely important. You learn from the data, right? And actually, if you look, you're mentioning about the enterprises, the way they look at that, look these technologies, about how is the same thing, how we are going to take advantage of the data we have. Because each of them believes that the data is kind of their, what the value is, right? Because they have unique data about their products, about their customers, their own customers and things like that. So how can I use that data, which is unique to me, to get more value, more than the competitors? So everything does start with the data. But then when you talk about the analytics and so forth, that they are kind of, you have now for analytics, you have assistants, like you have a Databricks, you have Genie, right? And I think you are going to see much more and more fusing between AI and data.
Final question, Jan. 5 years from now, where do you think we are?
5 years.
5 years from now.
These are the kind of questions you can only lose, right? Right, because you are going to be quoted maybe after 5 years. But that's basically, it's like maybe it's the best case scenario, because this means that people maybe still care about you. I think that 5 years from now, it's again, the easy one is like, we are, the transition we need to make today is about a lot, I was talking about reliability, it's about what I'm calling is like from the demo and production, right? The demos are always easy, right, as you know, because you need to find one particular kind of scenario, stories, which is really, really impressive. Now, when you go to production, that thing has to work not only in an impressive use case, it has to work in all the use cases, right? So that transition what is makes difficult, and you see that in everything you are doing. Like for instance, you write software, right? And how much time you spend in writing, a prototype for a particular feature, and how long it takes to put that feature in production, right?
Yep.
It's clearly, and with this AI, it's even much more difficult. Right?
Yep.
Because at least with the software, it's open box. You can debug it and so forth. You have tools and you can say, oh, this is instruction, this is wrong. It should be, I don't know, a plus instead of a minus. You fix that and it's going to work, right? But with large language model, black box is much harder. So you should assume that the delta between the demo and the production will be much higher.
Pretty high.
So we are going to have to work for quite a bit. But as we are going to work, we are going to start using this things more and more as like they are called assistants, right? Very powerful assistants, and it will. I think that as they are going to become more reliable, as you are going to trust more, and they are going to be far more effective, right? Mm-hmm. It's like think about some intern, someone you are working with. It's like. Let me, and why I'm saying about this reliability is so important. Let me ask you this one: do you prefer to have a coworker or someone you depend on, right, who is brilliant, but is not reliable? I mean, he's saying something he's doing and he's doing, it's not happening. Or someone, maybe he's not as brilliant, right, solid, but is absolutely reliable. Whenever she or he says he's doing something, he's done. You can forget about it. Think about that, right? Why would it be different in this case? So that's kind of journey. So I hope that in 5 years we are going to have really kind of reliable AI systems, and it will do a lot of more work. It will do, quite a bit probably of my own, research.
Excellent. Well, that's all we have the time for, Ion. Thank you so much for being here.
You.
Ion Stoica, ladies.